Folks, I had a great question from one of you about computing these pairs of limits. The limit as x approaches infinity of this rational function, and for the same rational function, we'll look at the limit as x approaches minus infinity. So let's give it a shot. Trying the first question, we've got the limit as x approaches infinity of 36x squared plus 3x all over 16x to the fifth minus 2x. And our strategy is to multiply by 1 over x raised to the highest exponent as seen in the denominator. So we're going to multiply this by 1 over x to the fifth over itself. Remember, we're just multiplying by 1, and then we're going to distribute this expression to both of the other two. When we do so, we end up with the limit as x approaches infinity of 36x cubed still plus 3 over x to the fourth, all divided by 16 minus 2 over x to the fourth. Now, just like we kind of rationalized our way through these problems before, notice that as x gets large, both of these components will tend towards 0. And so this limit is going to be the same as this limit right here, the limit as x approaches infinity of 36x cubed all over 16. But look what happens to this entire expression as x gets large. As x goes far to the right, x cubed becomes even more positive, and so this expression becomes a large positive number, and so that's how we rationalize the limit as infinity. For the second question, we do the same work. We'll have the limit as x approaches negative infinity of our 36x squared plus 3x all over 16x to the fifth minus 2x. And just like we did in the first example, we'll multiply by 1 over x to the fifth. This part is identical. And so cleaning all that up, we get the limit as x approaches minus infinity. And then here again, we'd have the same 36x cubed plus 3 over x to the fourth, all divided by 16 minus 2 over x to the fourth. But in this case, so we'll say this limit is the same. This expression is still going to go to 0 as x becomes a large negative number, right? 3 over negative 1,000 to the fourth power, that term is going to approach 0, as is this one. So we're left with the limit as x is approaching minus infinity of 36x cubed over 16, just as before, but this part's different. As x becomes a large negative number, the expression x cubed becomes a large negative number, and when I take that large negative number and multiply it by 36 over 16, that result is again a large negative number, which is why this limit comes out to be infinity. Now folks, here the question was to find the limits. If we were to state any horizontal asymptotes, the answer is there is none, or there are none. Because the limits, neither the right-hand limit nor the left-hand limit as x goes far to the right. Folks, I misspoke there. So neither the limit as x approaches go far to the right-hand behavior, it doesn't approach a finite value. And the limit as x goes to negative infinity, that is the left-hand behavior, it does not approach a finite value. So that's why there are no vertical asymptotes in this problem. Folks, I hope this clarifies. If not, let me know.